Hello everyone, welcome. In this video, I will be covering section 12.2, which is about vectors. What is the difference between a vector and a scalar? A scalar is a real number, whereas a vector is a quantity that has both magnitude and direction. It should have both real valued magnitude and a direction. You have seen vectors earlier in your Calc 1 and Calc 2 classes. The examples would be force, velocity, acceleration due to gravity. All these are examples of vectors, which has both magnitude and direction. The vector is used to indicate a quantity such as displacement, velocity, or force that has both magnitude and direction. A vector is often represented by an arrow or a directed line segment. The length of an arrow represents um, the magnitude of the vector, and the arrow points in the direction of the vector. We denote a vector by printing a bold-faced V or by putting an arrow above the letter V. On top, there is an arrow. Suppose a particle moves along a line segment from point A to point B, then the corresponding displacement vector V is shown in figure 1. Has, and this vector has got the initial point A, just this point, and the terminal point B. And the terminal point B. The initial point is also called the tail. The terminal point can be called as a tip. And we indicate this by writing V boldface or V on top an arrow equal to vector AB. So it starts at A and ends at B. So the length of the vector is the length of AB, and then it is starting from A and ending at B in the direction of AB. Notice that the vector U, CD, vector CD has the same length and the same direction as V. So if you look at this, the other one, so it is also having the same length as the previous vector V, and it is also in the same direction as AB. These two are parallel to each other. The length of them is the same. We say that U and V are equivalent. Are equal, and we write vector U equal to vector V. If you're writing, then you may have to put an arrow on top. The zero vector denoted by 0 and vector on top, 0 vector has length 0. It is the only vector with no specific direction. How do you add two vectors geometrically? How do you add them algebraically? To add two vectors geometrically, we use either the triangular law or the parallelogram law. So if you have a vector which is starting at A and ending at B, then there is another vector V which starts at the terminal point of U and ends at C, that direction. Then the sum of the vectors U plus V has a initial point, which is the initial point of the first vector, and joining to the terminal point of the second vector. So the one which is shaded in blue is U plus V. So it is by triangular law. Parallelogram law, it's kind of similar idea. So we have U vector and the V vector. And then by earlier discussion, u plus v is this diagonal. And in parallelogram, we know that the two opposite sides are parallel to each other. So if you use that fact, then it's also equal to v plus u. So incidentally, it proves that u plus v equal to the vector v plus u. That means vector addition is commutative. Algebraically, we add the corresponding components of the vectors. So we add the corresponding components of the vector. We will see what we mean by components in a bit. Definition of vector addition. If u and v are vectors positioned so that the initial point of v is at the terminal point of u, then the sum u plus v is the vector from the initial point of u to the terminal point of v. Then definition of a scalar multiplication. If C is a scalar and V is a vector, vector has both magnitude and direction. C is just a magnitude. Then the scalar multiple of the scalar multiple CV is a vector whose length is absolute C times the length of V and whose direction is same as V if C was positive. And it is the opposite to V if C is negative. If C equal to 0 or V equal to 0, then CV would be equal to 0, equal to the 0 vector. Algebraically, to find CA, we multiply each component of A by the scalar C. So if you look at this picture here, V is the first line in blue. The second one is 2 times V, which is the length of that vector is 2 times the length of the vector V, and it is in the same direction as V. Half of V is half the length of the first vector V, and it is in the same direction as V. Negative V has the same length as V, but it is opposite direction to the vector V. Negative 1.5 V is 1.5, the length of it is 1.5 times the length of vector V, but it is in the opposite direction of V. Two non-zero vectors are parallel if they are scalar multiples of one another. In particular, negative of V is negative 1 times vector V has the same length as V, but points in the opposite direction. We call it negative of V. So it is, look at this picture here, look at this one and this one. So they are opposites of each other, and the magnitude wise they are the same. The difference between two vectors. By difference of u minus v of two vectors, we mean u plus negative v. So we can construct u minus v by first drawing the negative of v, negative v, and then adding it to the vector u by the parallelogram law as in figure 8a. So if we choose, if we look at this picture here, A, so we have vector u, and then you are given vector v. They both start at the same point. Now, if you take opposite of v, that will be in this direction. Now you complete the parallelogram and consider the diagonal. That would be u minus v. So it is same as u plus negative v, because you can consider this to be negative v as well. So we are actually adding u with this negative v, and then we can either say by triangular law or by parallelogram law that the diagonal of that parallelogram becomes u minus v. Alternatively, v plus u minus v is equal to u. The vector u minus v, when added to v, gives the vector u. So we could construct u minus v as in figure 8b by means of triangular law. Notice that if u and v both start from the same initial point, then u minus v connects the tip of v to the tip of u. If they both start at the same point, for example, this one, they both start at the same point, then u minus v and u minus v connects the tip of v to the tip of u. So this is the difference. This is how we interpret the difference between the two vectors. So one easy way to remember whenever you have to say what PQ is, let's say this is P, this is O, and this is Q. And if you have to, when you consider the PQ, that will be OQ minus OP. Okay, this vector would be OQ minus OP. That will be the directed line segment from P to Q. What are components of the vectors? For some purposes, it is best to introduce a coordinate system and treat vectors algebraically. It's easy to treat vectors in terms of components. If we place the initial point of a vector A at the origin of a rectangular coordinate system, like this one here, then the terminal point of A has the coordinates of the form parenthesis A1 comma A2. When we write A1 and A2 as an ordered pair, the first A1 represents the x coordinate, the second A2 represents the y coordinate of the point. Same way in space, it's written as in terms of parentheses an ordered triple, A1, A2, A3 in that order. So A1 represents the x coordinate, A2 represents the y coordinate, and A3 represents the z coordinate of the point in space. So this depends on whether our coordinate system is two-dimensional or three-dimensional. So an ordered pair, just x and y, is two-dimensional. An ordered triple, x, y, z, would be a point in space. These coordinates are called components of A, and we write A with an angle bracket, and we write A1 comma A2 with an angle bracket, A with components A1, A2, A3. So if we write like this within the angle bracket, then it becomes that it is a representation of the vector in terms of component form. We use the notation angle bracket A1, A2, angle bracket A1, A2 for the ordered pair that refers to a vector starting from O to the point A, let's say. They're starting from O to the point A in space. So that is the vector. So it is the directed line segment that is represented in the angle bracket form. So if I write OA vector here, I should write like A1 comma A2. If you just say point, then In coordinate, it's just an ordered pair like this. Same way here, OA in three-dimensional should be written in the component form as A1, A2, A3 inside an angle bracket. And if you write the point A, it will have just the coordinates A1, A2, A3. That's an ordered triple. Uh, Please watch the next part of the concept video for this section, where I will continue with this section material, let's say vector representations and the other things, some problems in the magnitude and length, and all this material will be covered in my next part of the video for this section, which is called part B.